Floor diaphragm is very important when you are analyzing a building using software. It evenly distributes the lateral load on each structural element. So, when you are analyzing a building, you must apply floor diaphragm on each floor to get the accurate result. The process of assigning floor diaphragm is different in different softwares. So if you don't know how to assign floor diaphragm in STAAD Pro software, in this video I am going to discuss about this, how you can assign floor diaphragm in STAAD Pro software. I have already make a video on floor diaphragm topic, so if you want to know what is floor diaphragm, how will it impact the result of analysis, you can watch the video. It is available in my channel, and also I have shared the link in I button. You can click on this. So for example, I have taken this pre-model B plus G plus 5-story building. So I have already modeled the structure and also assigned the section and material properties, and also assigned some primary load cases. So if you don't know how to model this building and how to assign the load, you can watch my video. The link is given in I button. Under dead load, I have considered wall load, floor load and stair load, and also the load which is acting due to the basement in the beams, and here you can see. And in live load, I have considered the stair live load and also the floor live load, and here you can see them. So these are the primary loads I have considered in this building. So this dead load and live load basically define the floor mass of each floor, and these floor masses will be used when you are going to apply floor diaphragm on each floor. So I'll discuss these things in detail later. So now I'm going to show you how you can assign the floor diaphragm on each floor. To apply floor diaphragm, you must open the specification page. That specification page you can access from menu bar. You can click on this command menu bar, and then you can click on this masters or slave specification page, and here you can see the floor diaphragm tab is available, or you can use this specification page toolbar. This is available here, so you can click on this, and then you have to click on this note tab, and here you can see this note specification page is here, and here you can see the floor diaphragm option is available. You can apply the floor diaphragm using this master or slave option also. Previously this floor diaphragm option was not there. They have newly introduced these things. Previously if you want to provide the floor diaphragm, you had to use this master or slave option tab. Okay, so now they have added these features. So using this floor diaphragm option, you can easily assign the floor diaphragm on each floor. In this window, here you can see first you have to provide the diaphragm number. In our case, I will provide the diaphragm from ground floor level. Since in this building you can see basement is there, it's mean the ground floor will be RCC slab. So that's why we have to provide the floor diaphragm in ground floor also. But in normal building where basement floor is not there, we will not provide the floor diaphragm in ground floor, because in ground floor there is no RCC slab. But in the building where the basement is present, there you have to provide the floor diaphragm in ground floor, because the ground floor will be casted with RCC slab. So in our case, the diaphragm for ground floor will be 1, and for first floor it will be 2, and so on. So this is how you can provide the diaphragm number. And here you have to provide the floor level. So if the floor is not inclined, this time you just provide the height of that floor. or if is your floor is inclined, this time you have to provide the Y range value. Here you have to mention which nodes you are going to include in that diaphragm. Sometimes what happen, due to the stair positions or lift positions, you may not consider the all the nodes will be include in this diaphragm, because in the stair position there is no slab, in the lift position there is no slab. Stair position there is a slab, that is inclined slab, not inclined slab, right? So that's why we can exclude them from the diaphragm assignment. So that's why this option is here. If you want, if you exclude some node from diaphragm assignment, you can do that by using this option. This time you have to click on this diaphragm floor range checkbox, and then you have to select the nodes, or you can select the nodes by using floor range. So this is how you can exclude some nodes from floor assignment command. Okay, and now here the last option you have to mention, that is the master node information. So this is very important. So I am requesting you again, if you haven't watched the floor diaphragm video yet, which I have uploaded in my channel, please go and watch that video. You will understand why this master node information is required when you are going to assign the floor diaphragm. I have clearly explained those things in that video, so you can watch that video for your understanding why this master node information is required, and the link is available in I button. You can click on that. Okay, here you have to provide the master node information. You can provide the master node information in two ways. Either you can select this calculate option, or you can select this option. So if you select the calculate option, it means the software will calculate the position of the master node using the floor masses. So obviously you have to define the floor masses, so I will tell you those things later. So first I am going to show you assign floor diaphragm using select master node option. So just I'm going to click on this, and here you have to select the master node. So which one will be the master node, I'm going to tell you. So first I'm going to show you the ground floor layout plan. So here you can see this. So this is the ground floor plan. Okay, so here I am just assuming whatever masses, whatever load I have applied in this ground floor, I am just assuming the center of mass for this floor is situated at 111 node. I'm just assuming it. Okay, I haven't calculated anything, just I'm assuming. Okay, if the 111 node is the center of mass for this floor, obviously we will consider this node as a master node. Sometimes what happens, sometimes the position of the center of mass may not coincide with the existing nodes, right? So this time you have to insert the node at that position. So suppose if the center of mass is coming here, so I have just added here a node. You can see 487 node I have added. So if the position of the center of mass come here, which may be outside of the member, right? So this node is totally isolated from the building. Okay, so this time also you may add that node, and you have to define this node as a master node for this floor. Okay, and also this node may come within the member. If it is come within the member, so also you have to add the node within the member. So it's totally depend on the load value where the position of the center of mass of that floor will come. Okay, so the position of the master node may coincide with the existing node, so this time you don't need to insert any node in the structure. But if the position of the master node if not coincide with the existing node, suppose if this node come within the member or outside of the member, this time you have to insert a node, and that node number you have to mention in master node information. Okay, so when your master node will be outside of the member, this time you will see a warning like this. You have to ignore this warning, because you are going to mention this node as a master node, right? So And here you can see STAAD is also saying the same thing: ignore if the master or slave joint. So in our case, obviously it is a master node, so we can easily ignore this warning. So this warning is coming due to the disjointed structure. Okay, so obviously when we are inserting a node which is totally isolated, which is totally not connected with the any other member, obviously that will be a disjointed structure, right? So that's why this warning is coming. But when you are mentioning that node as a master node, so you can ignore that warning easily. Okay, so now in our example, I am assuming this master node is 111, and the y coordinate for this floor is, that is 1.7 meter. So this information also is required when we are just going to assign the floor diaphragm. And now I'm going to open again that floor diaphragm page, and here you can see it. So here I'm just going to provide the height is 1.7 meter, and here I'm going to select the master node, that is 111, and here I'm going to uncheck this because I'm just going to include all the node in the diaphragm. So if you don't want, this time you can check this. Okay, so now I'm just going to apply add button, and here you can see the diaphragm is added with a master node, that is 111, and the height is 1.7. so this is how you can add the floor diaphragm on each floor. Okay, same method you can follow, and just I'm going to run this, and here you can see there is no error. Okay, the analysis is going on, and the analysis is completed here, and here you can see the floor diaphragm I have provided. This is the height 1.7, and this is the node I have defined. Okay, this is the master joint number. Okay, so this is manually I have defined, but you know, this process is very complicated because each time you have to calculate what will be the center of mass for each floor also, and so it is time consuming process. So why will you do that? Obviously you will choose a option so that easily you can assign the floor diaphragm. So that's why you have to choose this second option. Here you can see this option you have to choose. I mean, the software will automatically calculate the center of mass. Okay, so that option obviously it is you want to choose, right? So if I select this option and if I change this, and now if I run this file, you will see an error message. This error message is coming because you haven't defined any reference load cases. So when you are going to select the calculate option in master node information section, so you must define reference load cases, otherwise system will not be able to calculate the CG of mass of each floor. Right, now I'm going to show you how you can define the reference load. In reference load, what load we are going to consider, that is a cause. Now you have to know in reference load what loads you are going to consider. In general, we consider the seismic weight in reference load cases for calculation of center of mass also, because when the lateral load will come, this time we will see the effect of floor diaphragm. So the effect of floor diaphragm you will not see when the dead load and live load will act, right? So you will see the effect of floor diaphragm in lateral load only, right? So that's why obviously whatever load or whatever seismic weight we are considering for this building, this weight you should consider to calculate the center of mass of each floor. That's why you are going to use the seismic weight. And if you don't know what is the seismic weight of a building, I will recommend you to see the IS 1893 part 1 code. There you will see would have defined seismic weight, that is full dead load plus 25 to 50% live load depend on load intensity. So each and everything I am going to show you how you can define the reference load cases. So to define the reference load cases, you must go into the load page. So if you click on this load page, here you will see in right side the load page is available. So here you have to click on this definition tab, and here under this definition you will see there is a reference load definition. So click on this and click on this add button, and now you have to define a name for this reference load. So I am not going to give any name, so whatever by default name it is, I am just keeping it. And here you have to change it to mass, otherwise software cannot detect it as a mass modeling. So that's why you have to select load type as a mass, and now then click on this add button. Now close this. So if you want to add the reference load graphically, you can do that, but it will take too much time, because in reference load we are going to apply full dead load, right? So this load I am going to apply in reference load also, but if you do that thing in graphically, it will be a time consuming process. So that's why I will recommend you don't assign reference load using this graphical user interface option. So I'm going to show you very shortcut method for this. So just you need to go in this editor, STAAD editor page. So click on this, and here you have to go to the load cases, and here you can see after this reference load cases, at load case number 9, here you can see this is the dead load I have defined. So just I am going to copy all these loads, and it will be up to this, because I'm going to apply full dead load in reference load cases. So that's why I'm just going to the all the dead load, I'm just going to copy, and now I'm going to paste this dead load in notepad. So now I'm going to open notepad. I have pasted these dead loads in notepad because I want to change the syntax of these dead loads, because reference load have a different syntax, right? So that's why I have pasted it here, so that I can easily change the syntax. So I'm going to show you how you can do this. So first of all, I am going to delete these two load. These are the lateral load which are acting in the ground floor beam because of the basement. So I'm just deleting here, because this load will not be added in seismic weight or seismic mass, right? And here this minus sign you have to omit, because you know the mass cannot be minus value, right? It will be always positive value. So that's why you have to omit the minus sign. And here you can see this load we are applying only vertical direction, but when we are going to add this load in reference load cases, you have to apply this load in x and z direction also. So what the change you have to do here, first one is you have to remove this sign, minus sign, and second one you have to apply this vertical load in x and z direction also. So that is what I am going to do here by using replace, find and replace method. So I'm going to show you how you can do this. So first of all, I want to remove this minus sign. So first I'm going to click on this edit, then replace, and here you have to write gy space minus, and it will be replaced with gy space. So you have to give this space, otherwise what will happen, there will be no space between gy and this value. Okay, now I'm going to replace it, and here you can see all the minus sign is omitted, and here you can see the minus sign is there. Also you have to remove this minus sign, so that's why what I'm going to do, I'm just going to write F load minus and space minus, and here I'm also going to write F load space, and now I'm going to replace it, and here you can see all the minus sign I have removed, and this minus sign also you have to remove. So these are the load we are applying in y direction. So same load we have to apply in gx direction and also gz direction. So how you can do that, I am going to show you. So just I'm going to copy all this load, I'm going to paste it in editor page. So in reference load cases I'm going to paste this. So this is the reference load case, here you can see I'm going to paste it here. So this is the load for y direction. Same thing I have to apply for x direction and also for z direction. So this is the dead load value. So for understanding what are the load I am pasting here, I'm just writing here. So this is basically dead load. So this star symbol is used to add some text in your editor page so that I can easily understand which one is for dead load and which one is for live load and which one is for y direction, etc, etc. So this load is for y direction, so I'm just going to write here y, and now here I'm going to paste the load for x direction, right? So again I'm going to the notepad page, and here I'm going to replace gy with gx. So now I have replaced here gy with gx, and this value will be x obviously, and now I'm going to copy this. Again I'm going to paste it here in. So this load we are going to apply in x direction, and this load we are going to apply in y direction. Again I am going to apply same load in z direction. So again here I am going to replace this gx value with gz, and here this value will be z. And now I'm going to select all of this and copy it. Now I'm going to paste it here, and here you can see I have added this load in z direction. So only the dead load I have added in reference load. So let me show you, just save it. So here you can see in reference load cases all this load I have automatically applied, and here you can see all the load is applied in 3 direction x, y, z. Now I am going to show you how you can add the live load here. So just I'm going to the editor page, and here I'm going to copy all the live loads here, and now I'm going to paste it in notepad. And here I have to remove this minus sign. Same method I am going to follow. And here I am going to remove the load on roof floor. So this is the load on roof floor, I am going to remove it, and this is the load on above roof portion, so I'm going to remove them. And here all the 3 magnitude will be 0.25 into 3, it's means 0.75, because as per IS 1893 if the live load value up to 3 kN per meter, it's mean we can consider 25% of live load value, so that's why it is coming 0.75, and also here it will be 0.5, this value will be 0.5. so here all the load below 3 kN or up to 3 kN, so that's why only we will consider 25% load. So also this value will be 0.5, this value will be 0.75, and this will be 0.5. that's it. So this is the load for y direction. I'm just going to copy this, and now I'm going to paste it in the reference load case section. So here I'm going to add live load. First one will be for x direction, then y direction, then z direction. So this is for y direction. Here it is. Again I am going to the notepad page. In notepad page I'm going to replace gy with gx. And now I'm going to paste it here. Again I'm going to replace this gx with gz. And now I'm going to paste it here. So that's it. Now I have added all the reference load cases. Let's check whether there is any error or not. And here you can see there is no error. It's mean we have successfully added the reference load cases, and here it is. Now I am going to the reference load pages. Here you can see I have selected here calculate option. Now before run this analysis, I want to check whether the reference load is provided before the floor diaphragm or not. So let it check. So in this model the reference load is provided after floor diaphragm command. So you have to move this reference load before the floor diaphragm command. So that is what I'm going to do. I'm going to cut this, and now I'm going to paste it before floor diaphragm command. And here it is. I have moved the reference load before the floor diaphragm command. And now I'm going to save it. And now I'm going to run it. So here you can see there is no error is coming. Software is successfully completed the analysis. And here you can see software have automatically calculated the center of mass and the master joint node it have created. That is, you can see that is the 487. Now I'm going to assign the floor diaphragm in other floor also. And now I'm going again this floor diaphragm command, and I'm going to copy this. And I'm for first floor, the floor height is 4.75, so I'm going to write here 2, and it will be 4.75. And for second floor, this height will be For second floor, this height will be 7.8. So this is how you can assign the floor diaphragm for each floor. So now I'm going to save it, and now I'm going to close it and run it again. And here you can see the software have automatically calculated the center of mass, and also it created the master joint automatically. So this is how you can apply the floor diaphragm in each floor. And this reference load can be used when we will perform dynamic analysis. So you can check this video. Here I have shown how you can perform dynamic analysis in STAAD Pro software. So thank you for watching this video. So please subscribe for your support. So if you think this video help you to understand how to assign floor diaphragm in STAAD Pro software, please like this video and share it to your friends.